in progress.
Hope I am audible to you all. Good evening, students. The course we are starting today is Level 5 Computing, Client and Server Side Technologies. Do you have any idea about client and server? What actually client and what is server? Client is any user or a person or a device that requests resources from a server. In simple words, you can say that client is dependent on server, whereas server basically provides services or resources or data to client over a network. Today, what we are going to learn? We learn about transport layer protocols used in computer networks. The concepts that we are going to study over here are about the network socket. Network socket concept, feature, and functionality will be discussed. Then in second is the purpose of the transport layer protocol. The third is the transport layer protocol's implementation. What is a network socket? Over here, the description of socket as a programming will be discussed. Basically, socket as a programming interface that provides the communication end for the processes on a network. Socket components is IP, address V4 and V6 will be discussed, and the port number will be viewed. Later, we will discuss the concept of reserved and ethereal ports numbers. Then we will learn about the types of the sockets, stream sockets, and data sockets. Then we will have traditional socket lifecycle, how it is created, configured, used, and closed. Then blocking versus non-blocking operations from sender to receiver. And then IPC, that is inter-process communication. How does a socket work in a computer network? Socket provides bidirectional first in, first out communication facility over the network. First in, first out means FIFO. FIFO represents the communication facility over the network, over any network. First in, first out communication means that the data packet or any sort of the communication that is done at the beginning will be served first and will be transferred to the receiver in the first place. A socket connecting to the is created at the end of the communication. The socket is placed at the end of the communication. Each socket has a specified address. The address is composed of an IP address and a port number. Sockets are generally employed in client-server applications. The server creates a socket, attaches to its network port address, and then waits for a client to contact. Once the client creates the socket and then attempts to connect to the server, when the connection is established, the transfer of data takes place. Now, the term socket will be discussed. A socket is one endpoint of the two-way communication link between two programs running on the network. The socket mechanism provides a means of inter-process communication, IPC, by establishing named contact points between which communication takes place. These are the socket components, IP address, V4, V6 we will discuss, and the port number. They are two components of the socket. A socket is a networking defined by the combination as an IP address, V6 or V4, and a port numbers. These two elements work together uniquely in identifying the specific process or services of the network host. IP addresses uses a 32-bit address, typically representing dotted decimal notation. Then IP6 128-bit address, typically representing in a hexadecimal notation, and examples of both are mentioned along with their description. IP addresses are used to locate devices on the network. Ports, a port number is 16-bit value from 0 to 65535. Socket components, port numbers differentiate between different applications or services running on the same device. For example, a web server typically uses port 80 or 443 for HTTPS, while an email server might use port 25. The IP address identifies a specific computer or a device that is being used for the communication. Port number identifies a particular application or service running on that device. Port number identifies particular application or service running on that device. That is a difference between the identification of an IP address and the port number. You must remember it. Then they form a socket, which is the endpoint of the communication channel. Then concept of reserved and ethereal port numbers. Reserved ports are from 0 to 1023. These ports are assigned to well-known network and protocols. There are a number of ports that have been assigned to different protocols, as you can see. Port 21 is assigned to FTP, that is File Transfer Protocol. Port 22 is assigned to Secure Shell. Port 25 is assigned to Simple Mail Transfer Protocol. Port 53 assigned to Domain Name System. Port 80 assigned to Hypertext Transfer Protocol, and 443 is assigned to HTTP Secure. They are globally standardized. And typically require elevated privilege to use. Ethereal ports. These ports are used temporarily. Ethereal means temporary and for a shorted time period. Dynamic connections initiated by client applications when they need to communicate with server. When a client application initiates a connection, the operating system typically assigns a value available ethereal, and after the communication session is completed, the ethereal port is released and it is assigned to another application. So in this way, multiple clients have a chance to connect with the same servers without any conflict. The term ethereal means temporary or short-lived, that I already discussed. Then we have the reserve ports are likely to permanent addresses for common services, while ethereal ports are likely temporary addresses used for specific connections. Reserve ports are standardized and well-known, while ethereal ports are dynamic. And this slide shows you the difference between the reserve and ethereal ports. You must know. Understanding the distinction between these ports is crucial for network administration and applications. And then the third bullet, they have discussed the port types is crucial for network administration and application development, means the areas where they can be used. Then we have the types of sockets. There are two types of sockets, datagram socket and stream socket. Datagram is a type of network which has connectionless point of sending and receiving packets. The letters posted in the box are collected and delivered to the letterbox receiving socket. A streamline in computer's operating system, a stream socket is a type of inter-process communication socket or network socket, well-defined mechanism for creating and destroying connections and for detecting errors. A connection is established between the phones and a conversation takes place. Next is the socket. While socket creates established a communication endpoint, then it is configured for specified settings like protocols and address. And the socket is then used for sending and receiving data. Finally, it is closed release and it is done in different steps. The first step is of creation, that is create. A socket is created using a function like socket. In Python or C, two programming languages are being used in creating the function of the socket. Specifying the communication domain, for example, IPv4 and IPv6, and socket type, for example, stream or datagram. Number two, configure. This involves binding the socket to an address using bind. Bind function is used for configuring. If it is a server socket and connecting to its remote address using connect, it is a client socket. Protocol like TCP and UDP are also specified during this stage. In this stage, though you will specify the protocol TCP and UDP, whichever the protocol is. Then the third is the user. Data is transmitted over the connected sockets using functions like send and receive or write and read in some systems. This is where the actual communication takes place. Then the fourth one is close. One close communication is complete. The socket is closed using close to release the socket resources associated with this. The term close is used in order to complete the communication. Then we have the IP address identifying the specific computer or device. The port numbers identifies particular application. Together they form a socket, which is an endpoint of the communication channel. Then we come to the concept of blocking or non-blocking operations related to the socket. Send, receive, and then example. The sending process is blocked until the message is successfully sent, either directly to the receiver or placed in the buffer for later transmission. Receiver process is blocked until the message arrives in the and is received. Example, imagine a program waiting for user input. A blocking read would pause the program until the user enters something, and then program resumes execution afterwards. This is simple program. When you write a source code and when you try to run the program, there is a screen at the output that temporarily stops until any character or any value is entered by you or the user. And as you enter any text or value, the program resumes execution afterwards, means it shows you the output. Then we have the non-blocking operations, send, receive, and sample. In non-blocking, send initiates sending processes, but return immediately even if the message isn't fully transmitted, yet the program can continue with other tasks. A non-blocking receive attempts to receive data, but returns immediately even if no data is available. The program can then check for the data later. For example, the example of non-blocking operations, a web server using non-blocking sockets can handle multiple clients' requests concurrently. When the request arrives, the server does not wait for that request to be fully processed before accepting it. It means that once the request is received by the server, that request is completely processed before accepting the other request. Then we have the IPC, that is inter-process communication. Refers to the mechanism that allows different processes on a computer to exchange data and synchronize their actions. There are key concepts: independent processes, communication channel, message queues, shared memory, and semaphores. Independent processes are typically associated with each other, meaning they do not directly access each other's memory or resources. They are working on independent memory or resources. Communication channels provides way for processes to communicate, each as pipes, allow unidirectional flow of data or flow of packets between the processes. Message queues enables asynchronous message changing between the processes. Then we have shared memory. Memory sharing, multiple processes can share and access memory for the faster data sharing or faster data transmission. Semaphores used for synchronization access to share resources and preventing their race conditions. Synchronization IPC mechanism also facilitate the coordination of processes, ensuring that they operate in a correct order and avoid conflicts. Why IPC important? Parallelism, resource sharing, modularity, and system. These are the important factors. Parallelism means multiple processes running concurrently, improving the overall speed and efficiency of the system. Resource sharing is also different processes sharing data efficiently and without compromising their individual security and stability. Modularity, breaking down complex tasks into smaller and manageable form, and then communicating and collaborating by processing them. System stability, IPC can prevent a single process from crashing and the entire system by isolating errors within the process. Then we have the example of IPC: producer, consumer product, client server applications, operating system kernels, and graphic user interface. Pipes, message queues, shared memory, semaphore sockets, and remote procedure calls. Then come to the next topic, that is transport layer protocol. We will over here learn the purpose of the transport layer protocol with respect to the OSI 7-layer model, role of transport layers to facilitate communication between devices, end-to-end communication. Key expect segmentation resembles for the message and this establishment, maintenance, termination of devices, error detection and correction, congestion control over wire control, multiplexing, implementing transport layers, including but not limited to transmission control, TCP and user datagram protocols. These are the key topics that we are going to discuss. Transport layer respect to this situated at the 4th layer of OSI model. OSI model is basically a 7-layer model that helps the devices to communicate. They are basically the protocols, different layers defining different protocols and working and making possible for data communication and processing of data transmission possible, and is responsible for the end-to-end communication between applications, managing data transmission and ensuring reliable delivery. It acts as a bridge between the upper user-oriented layers and lower network-dependent layers, handling tasks like segmentation, error control, and flow control. The role of transport layer to facilitate is crucial for facilitating reliable end-to-end communication between the devices. It acts as a bridge between network layer and application layer. Bridge means network layer and application layer. In between, there is a transport layer. Providing services like segmentation, error control, flow control, multiplexing to ensure data is delivered accurately and efficiently. Key functions, end-to-end communication, segmentation, assembling, error control, flow control. Purpose of this protocol is to provide reliable, effective data transmission between applications. Managing tasks like segmentation, connection establishment, ensure data is delivered accurately and is in correct order. End-to-end communications, segmentation resembles this, all this is discussed before. Then we have the multiplexing and demultiplexing. Transport layer enables multiple applications on the device to communicate concurrently over a single connection like service. The transport layer can provide both connection-oriented TCP, like established a reliable ordered connection before data transfer, and connectionless service like UDP that offers faster, less reliable less reliable data transfer. Error detection and correction is the next topic, and that is related to the method to identify and fix the errors that occurs during transmission and storage. They are broadly characterized. Error detection techniques identify whether error has occurred, while error correction techniques not only identify the error, but also they try to fix it. Then we have the concept of multiplexing and demultiplexing. Complementary processes, multiplexing combines multiple signals in a single channel, while demultiplexing separates them at the receiving end. This is a basic difference. They are essential for efficient data transfer and resource sharing. Different types of protocols that are implemented. One is the UDP and the other one is TCP. TCP is connection-oriented, established a connection between sender and receiver, data transfer, ensuring reliable and orderly delivery. Reliable, orderly delivery, flow control, error detection, and correction. All these are the characteristics of the protocol. And then we have connectionless, unreliable, fast, simple, lightweight, and used for the protocol. That is the UDP. Different approaches. Why do UDP and TCP exist? Different approaches of communication between networks. For example, client server is required, typical cases like video game and all that. And there are considerations, reliability versus speed. We will consider these factors in TCP and UDP. Ordered and unordered delivery data, connection-oriented or connectionless, resource uses, network suitability, requirements for multitasking and broadcast, and software application requirements. TCP and UDP both exist because they prefer trade-off between the reliability and speed, catering to diverse network application needs. The TCP priorities reliable order delivery, while UDP provides the speed and low latency, and this is basically the difference. If you are asked to compare and contrast between the TCP and UDP, you may write these points. Then we have the role of the transport layer to facilitate communication between the devices. Application layer provides services to the segmentation, error control, and flow control, and it acts as a bridge between network and application layer. Then we have congestion control, VIA control, flow and congestion control are both techniques. They are both the techniques used to manage traffic, network traffic. Flow control focuses on preventing a faster sender from overwhelming the slow receiver, ensuring data transfer between specific nodes. Congestion control, on the other hand, provides broader issue of the wide congestion, aiming to provide the entire network from becoming overloaded. Then we have flow control purpose, mechanism, location, and example. Purpose of flow control is preventing the receiver from flooding the data it cannot process. Rate of data transmission between center and the flow control is basically the rate of data transmission to be regulated. Mechanism typically involves sliding windows where receivers just indicates buffer capacity to amount of the data secure. Location operates at the data link layer and transport layer. TCP high sliding window mechanism is a prime example of flow control. Congestion control purpose mechanism location an example. Just read these slides thoroughly and you will understand the function of each and every key function. Congestion control purpose to manage the overall flow of data within the network, preventing congestion and ensuring efficiency resources utilization. Then we have a mechanism, fast recovery, fast retransmission, slow employs various techniques like slow start, congestion avoiding based on the network conditions, location operate primary at the network layer and transport. See, they work on the network layer and the transport layer. Example is the TCP congestion control algorithms are used to manage network data, traffic, and prevent congestion. Then we have key differences, scope, goal, and mechanism. These are the flow control point-to-point this and congestion control network pipe. This is the key differences, or you can have them in the contrast and comparison in terms of scope, goal, and mechanism. After that, we have implementation of typical transport layer protocols, including but not limited TCP or usergram protocols. Say that transmitting layer plays a key part in network communication, utilizing both the protocols TCP and UDP, data transmission between applications or different devices. These protocols provide different ways to ensure data is delivered and reliable. Then we have network address communication using various approaches. They have which have the client server and peer-to-peer models. Each model has distinct characteristics and suit for different applications. It depends upon the scenario or for the problem, which client model is suitable for which sort of communication. Then we have considerations, that is TCP reliability, speed, and use cases. TCP ensures that data is delivered in correct order and without errors. Speed is achieved through connection of data approaches. Acknowledgement to receive packets and retransmission of lost packets. Then use cases is ideal application where data integrity paramount, such as web browsing, email, and file transfer. Then we have UDP reliability, speed, and cases. And similarly, like we have TCP UDP is connectionless, and TCP is connection oriented. That UDP does not guarantee delivery, order, or error-free transmission. Speed is faster because it does have the overhead of the stacking connection using the entire errors for this. Use cases, UDP is suitable for applications where speed is crucial. Some data loss is acceptable, such as streaming video, online gaming, and voice over IP. Then TCP order delivery, connection oriented numbers, knowledge and error checking, and accurate port. These are the characteristics. Just study them thoroughly, read them thoroughly. Connectionless, no sequence number, no acknowledgements, minimum overhead idea. Connectionless TCP is connection-oriented, requiring three-way handshake to establish a connection before data. UDP is connectionless, sending data without any prior setting. Now, contrast and comparison, connectionless, to connectionless, you could write the comparison and the differences between TCP and UDP. Then we have the connection here, overhead, reliability mechanism, header size, state management, and resource extents. After that, we have Network recovery, TCP and NVMe are fundamentally different network protocols, each with its own strength and weakness, making them suitable for different types of applications. TCP is designed for a reliable order, while UDP prioritizes speed and low latency. Reliability, ordering, communication oriented, suitable for this. All these are the properties of the protocols. Overhead, speed and low latency, connection unreliable, low overhead. UDP, TCP has a higher overhead due to reliability mechanism, which can lead to slower speed and comparing. UDP, slow latency or low speed and low latency, connection less and reliable and content overhead. Then we have it's not TCP is not suitable for multitasking and for due to the connection oriented nature, which requires a dedication connection. Then we have TCP and multi or broadcast connections, that is transmission control protocol, and incompatibility and multitask for broadcast. Software application requirements for TCP and UDP means reliable and order delivery. In TCP, connection oriented, suitable for slower than UDP, sample and congestion control. The similar way we do UDP, we have faster connectionless delivery, suitable for real-time applications and all that, lower overhead. UDP overhead, smaller, less processing overhead. Examples are mentioned where a slight delay or packet loss is less noticeable than slow prediction. No congestion control. UDP relies on this, and error handling is UDP relies on the application layer for error connection and detection, as it does not automatically retransmit the lost packets. This is the end of the session. My suggestion is that I go through these slides that I will be sharing. Thank you so much.